So we are going to solve the 6.56 problem from chapter 6 of the subject statics of rigid bodies. So the problem is determine the force in members VG, FG, and FH of the truss shown. So this is the truss and we are going to find the force in here, the FG, BG, and FH. So I have already drawn the free body diagram. So since we don't need this part here, so we didn't draw it. So here's the free body diagram. Notice that we divided the length here because we are finding the force in FG and FH, which is necessary for the length, and also here. So in the previous example in the 6.55, we have found that the force in B is 26.4 kilonewtons, which is can be found or which is found here. So now we are going to solve the moment of or the force in FDG. So we're going to do a summation. So in here, uh, we multiply the force to its perpendicular length of 36 right here to its perpendicular length of 1.2 and the 26.4 kilonewton to 6.75. We have the length here equal to this one at 4.5. We add this 2.35 meters and the 4.5, so it will be equal to 6.75 and then 20 kilonewton to its perpendicular length of 2.25 and this one of the force of FDG. So when adding this one, it will be equal to, and doing the math, FDG is equal to negative 75 kilonewton or just simply 75 kilonewton, and it is in compression. So second, we are going to solve the uh, FG. So still, but we have the triangle or the right triangle. We have solved the hypotenuse of this one, so it will be equal to 17. It is a trigonometric identity, so it can be found here. And then after doing the maths again, we have found out that force of F of G is equal to 56.1 kilonewton, which is in tension. And lastly, the we are going to find F of H. So we're going to do a summation again in the moment of G. So the answer of this last part, or the force of f of fh, is 69.7 kilonewton, and it is also in tension just like f of g. So thank you for listening.